Okay, go ahead, Chris. Start talking. Okay, hi, I'm Chris again. I'm still here. Yeah, I didn't actually have a speaker really for this month. So, like the title says, this is a little bit like hastily prepared and slapped together. However, the topic WebAssembly is something that I've been really interested in for a really long time. And I was able to get a demo together that I think is fairly interesting. It is kind of like low-level nerdery and like very little like front-end, nice, appealing, visually good stuff. So I apologize for that if that's not your bent. But hopefully I can kind of explain why what at first appears to be not that interesting stuff coming out on the console, the implications of it I think are really, really cool. So WebAssembly, how many people have heard of WebAssembly yet? So most people, maybe about half, so that's kind of cool. So what we're going to talk about today, we're going to talk about what WebAssembly is. I'm going to try to give some context around why and why it's important. And then I'm going to do a demo, and we can actually look at one of the other demos on webassembly.org as well. So first of all, to understand why WebAssembly is interesting and cool, I think it's fun to kind of like climb back into my Wayback Machine with me. How many people are doing web development in 1995? Okay, cool, like a few people. Okay, awesome. So in 1995, there was this browser called Netscape. And so I did my internship in college in 1995 at Nationwide Insurance, and I was mostly doing SQL and SQL Server, but I kind of had this side thing where I was building them some web stuff. And right during that summer, probably in the spring actually, Netscape version, I don't know, I want to say 1.0, maybe it was 1.1 shipped. And that version of Netscape had two new things in it. It had a language called JavaScript, which was brand new, and it turns out written by a guy named Brandon Ike, I want to say in like 10 days. And it had this language that everybody already knew about, which is this up-and-coming language that was getting more and more traction and people were excited about, called Java. And at the time, JavaScript was definitely the afterthought. It was like this really kind of like people saw it and they advertised it as like kind of almost a little toy for making your web pages more interactive. But if you wanted to do like serious hardcore software engineering in the browser, you wanted Java. That was like the tool that you were supposed to use to do that. And so it's obviously super interesting that like nowadays, Java in the browser is dead as a doornail, and JavaScript is like this user group that you're sitting at. So like, that's weird. What happened? Okay, so let's talk about why Java in the browser failed. It made me really sad because I was like a Java guy, man. I was like all over the Java. I did Java for 10 years. I ran the Java user group, all the things. So I was super sad that it didn't make it in the browser. But basically, why it failed mainly is Java was like a bolt-on virtual machine that ran outside of the browser. And basically, like, you could write Java applets and they took over this little tiny rectangle in the middle of your web page and you could do things there. But it was clearly bolted on. And it was clunky and it was slow. And it was like this bolted on thing and had not real seamless integration into the web browser. In very late versions of Java, you could finally talk to the rest of the web page from Java. But by that time, it was already almost dead and it was too late. So the idea of Java being a virtual machine in the browser actually gave us a lot of the same abilities that WebAssembly will, as we'll see here in a second. But it ultimately failed. But the idea of, wow, what if we could have a virtual machine in the browser and we could write whatever language we want, it's actually not new. We tried it once already, and we're like just going in this giant circle. And I just find that like super, super interesting. Maybe nobody else cares. But anyway, let's talk about WebAssembly. What is WebAssembly? WebAssembly, according to their website, WebAssembly or WASM is a new portable size and load time efficient format suitable for compilation for the web. What? What's that mean? Okay, what it really, really actually is, and this is why I thought context was cool, it's really a virtual machine for the web again. So what's different this time and why is it actually going to work? So here's what's different. WebAssembly is not a bolt-on separate virtual machine where you can execute code. It turns out as JavaScript got more and more mature, rather than this little interpreter that Brandon Ike wrote in 10 days, people optimized JavaScript so it would be really, really fast. And in order to do that, they basically had to add a virtual machine that executes your JavaScript, can do just-in-time compilation, excuse me, can optimize your code and do all sorts of low-level goodness and magic to make JavaScript fast enough. So all the browsers at this point in time have some kind of JavaScript virtual machine built into them. And what WebAssembly is doing is exposing the internal browser VM that's already there. So rather than being a bolt-on, we're saying like, what if we could like directly expose the virtual machine and possibly skip the fact or not care about the fact that JavaScript is the language that this virtual machine knows how to execute natively? What if it could execute whatever language that we want to? So I should have added a slide here. How many people already know what a virtual machine is? Okay, that's most people, but just for the people that didn't raise their hands. Really, really quickly, when you write computer programs, you compile those computer programs in whatever language that you wrote them in down into machine language, zeros and ones that your CPU, that little chip inside your laptop, can execute. If you have a different kind of chip, you need a compiler that can emit the right kind of instructions for whatever kind of computer chip that is. A virtual machine is basically an idea which says that what if instead of compiling into actual machine instructions that can execute on whatever CPU I have, what if I made up this pretend computer that had a set of instructions that I define and I compile into this pretend machine language? The advantage is that this pretend machine language, it's easier to translate that at the lower level into the actual machine language. And so that's the idea. And it also makes it really easy to make a compiler once that compiles into some pretend machine language format, and I don't have to write a separate compiler for every different kind of computer chip that's on the market. That's the basic idea of the virtual machine. So that said, exposing that means I can write in whatever programming language I want. The other thing that's different this time is cross-browser support. So WebAssembly, like, I couldn't believe this actually happened when I saw it happen. But WebAssembly is actually, there's commitment to support across Chrome, Firefox, and IE. Chrome, as you might guess, Chrome and Firefox are done, and Edge is still coming along. But there's actually like official support across all the browsers to be able to support it. So that's, what's that? Oh yeah, Safari 2. Sorry, my bad. I assume Edge becomes IE eventually. I don't know. I don't know how it works. Yeah, I'm sure it's like the future Microsoft browser, whatever it is, whatever they call it. I have trouble keeping track of all those things. But the point is, like, the Microsoft browser platform will also adopt this as well and is like underway with it. The other thing that's really, really important is it does have well-defined JS bindings. So when you build something in WebAssembly, you can talk to it and execute things from JavaScript. It's as we'll see, it's a pretty clean, easy to work with layer of talking between the two, and that's what I'll demo. That's what we'll look at together in code. So why would you want to do this? So first of all, I think it's really cool to be able to execute languages other than JavaScript in the browser. Thanks, Miles. Obviously, this is a Java users group, so like, yeah, that's a thing. And I'm not here to talk trash on JavaScript, but I like freedom of choice as a developer. I want to be able to choose what I want to use to do whatever I'm doing when it comes right down to it. JavaScript's got a ton better, and maybe I'll keep choosing it, but like not having to, I think is awesome. Also, there's some definite performance benefits that WASM promises. And especially if you're doing things like hardcore 3D graphics, whatever, in the browser, being able to optimize code by dropping down to a lower level language is interesting. So, is it ready yet? Kind of. We'll see like what are the things that are good now and we can do, and what are the things that are like stay tuned, coming soon. So what can I do right now? I can execute WASM format. So WASM format is like a binary format of these imaginary machine language instructions, basically. I think it's a little higher level abstraction than that, but I don't go look at the binaries to see what they are. I'm not that interested. So browsers right now, like Chrome right now today, stock Chrome can just execute WASM. I didn't have to go to Canary to do it. I didn't have to turn any Chrome flags on. I just brought up my WASM demo and poof, it worked. So that's pretty cool. And I'm pretty sure Firefox is the same way. There are compilers that can emit WASM, that binary format. And the key one is LLVM, which is a kind of a virtual machine compiler backend. I'm not an LLVM expert, but it's basically like a compiler backend that lots and lots of languages use. And so Rust is the example language I'm going to look at. Rust using LLVM can compile into this WASM format. So the two languages that you can actually practically do stuff with in WASM, so far, the ones that I can find working examples for are C and Rust. How many people have heard of Rust at all? Okay, so most people, actually, that's pretty cool. So Rust is a, I think it's mainly like a systems level programming language that Mozilla came up with. And it's a pretty low-level language designed to write operating systems and things at that level. It's basically, its niche is to be a more productive C. C is like a really old school language, been around forever, and Rust is trying to fill that same niche as C. So it's pretty low level. You can do things like memory management yourself in Rust. In C, yeah, you got to do memory management yourself. So they're both pretty low-level languages, and it might occur to you, and it certainly did to me, like, why am I limited to such low-level languages? Why aren't all the languages in the world just like jumping on this and building compilers that emit WASM? I will answer that question in just a minute, but let's go ahead and jump in and do a demo. So I thought it was really cool to actually do true language choice. I don't know Rust at all, so I'm just sort of like stumbling around, but I got a demo and was able to actually write some of my own Rust code and see it actually work in the browser. So I thought it would be really cool to see that. So let's jump into the code and then I'll actually run it, because the demo is frankly the least exciting bit, sadly. But let's start with a file of Rust. So for those that haven't seen Rust, hopefully this is I don't know what I'm doing either, but this was mostly self-explanatory. What's that? Font bump? Is that what you said? How's that? Everybody able to read that okay? Cool. So like most languages, I start with a main function. This main function is what gets executed when my WASM module loads from the browser. It knows how to translate print line, which is like the internal like puts or system out print line of Rust. It actually sends that to the console. It knows how to do that much. And then I'm defining two functions, add and multiply, that are self-explanatory, I think. Rust is a typed language, so I have to tell it my parameters and my return value are all int 32s. Something else that's interesting probably, or at least I'll give you a little context. These are all like take numbers and return a number type function. I actually tried and wanted to say like, oh, I think it would be cool to do some string manipulation. I'd like a little hello function that took a string and returned a string. Actually working with strings in Rust and then sending them back to the browser turns out to be non-trivial because I'm not yet an expert enough with memory management in Rust to know that like a string, well, I don't know how many bytes that is ahead of time. I got to allocate the right amount of memory, and then I got to deal with sending that back into the browser, and that was like too hard for me to do. So like literally writing a hello world function required more brain power than I had in the hours that I spent at it yesterday. So that gives you an idea for like what level we're at right now. We're like way down here. So I'll talk about like how that's going to get better here soon in a little bit. But right now, yeah, the only thing I was smart enough to do, I started with add and I created multiply myself. So yeah, not super rocket science-y there. So that's what the Rust file looks like. I'm cheating a little bit. Let's look at my index.js file. Well, I'll start with index.html. So I'm using Webpack. How many people are Webpack familiar a little bit? So Webpack is a bundling tool that takes care of like bringing all my JavaScript together in one file, maybe transpiling from one JavaScript version to another. Lots of like plumbing type work. There is a Webpack plugin which runs the Rust compiler and builds my executable for me already. So basically all I had to do was start with this example project, and as we can see here in my JavaScript, I can actually require Rust files and use them. And Webpack knows how to do all the work for me to be able to make that happen. So this require, actually Webpack is taking care of the details of running the Rust compiler on this file, emitting a WASM binary format. We can see it over here. Yeah, it's not so readable, it's binary, but there it is anyway. So Webpack takes care of running the Rust compiler, outputting the right thing when I make changes, and the way I interact with it through JavaScript looks like this. I'm using require, which Webpack gives me, and getting to this WASM module. It's also given me a few shortcuts to the WASM API. If I was using the raw WebAssembly API, I would have to do a little bit more work, but not a lot. I'm calling initialize. I'm passing this flag. I actually had to add this. When I first started working with this demo, it didn't work. What happened was I would load my functions, but by the time I tried to execute them, the runtime would have exited, and it would tell me, that runtime's no longer around, you can't execute that function anymore, which was kind of awkward. So I had to pass this extra flag in here to tell it, hey, don't let the runtime execute, please, because I want to actually be able to use those functions. Anyway, seems a little silly, but that's what I had to do. So this initialize actually like fires up the WASM stuff, and it returns a promise where my WASM module gets passed to me after it's loaded. This module is what contains the executable Rust stuff. And how I bridge that executable Rust stuff into JavaScript is with functions on that module object. And the only function that I'm using here is called CWrap. I don't know why it's called CWrap. I guess that gives you a feel for like, hey, it's designed to be talking to C mostly. I presume that's the case. In my case, I'm actually wrapping a Rust function, so it'd be nice if it was called something else, but never mind. I am wrapping an add function, and I need to tell it all the type information. So that's important when we're going from like totally different environments, one to the other. Somehow the system has to know how to map types from one environment to types in another environment. And the JavaScript primitive types, it knows how to do that with. In this case, I'm just using number. That's it. I had issues with string, like I said. So this says, hey, this function returns a number, and then that last argument is the parameters. I have 2, and they're both numbers. So I get back a function, a JavaScript function, from that module CWrap call. And then finally, once all that's done, I'm able to just invoke those functions as if they were JavaScript, because effectively they are. So just so you can actually see this is working, let's actually change this to lie, and we'll just like multiply it a times b. And in my code over here, now it should be 18 instead of 6. Did I get my arithmetic right? I hope so. Thanks, Dan. Okay, so I have the server running in that project. Over here, I have a compile task that just runs Webpack on it. And so if I do npm run compile, we can actually see it do its thing. You can see it actually compiles that Rust file. Okay, npm run serve. And now if I go back here and reload this hello world, we can see that it actually outputs hello world. It says I'm calling Rust functions from JavaScript, outputs the result of add and the result of our multiply, which is a lie. So it actually works. I can actually execute Rust compiled code in my browser. I know it's not visually cool, but for me, like the implications of it are pretty exciting. And yeah, that's my demo, such as it is. Let's see. So I promised like there was a question that I'd get back to, and that is like, why can't I use higher level languages like Ruby and Crystal and whatever. And it turns out there's some features that higher level languages expect from their runtime. The principal ones are a garbage collector. If you think about a language like Ruby, you never have to allocate memory yourself. You just make objects willy-nilly, and there's this thing called the garbage collector that keeps track of who's using those objects, and if nobody's using those objects, it cleans up that memory for you so that you don't run out of it. The other, memory management, you know, that's a typo, I'm sorry. Garbage collector and memory management, that's just different ways of saying the same thing. The other bullet point should have been threading. That's the other thing that most modern runtimes expect you to be able to have, or most higher level languages expect out of their runtime, is the ability to do threads. So those are the features needed by languages. here's the complete list of those features that are supported by WebAssembly currently. As you can see, there aren't any. However, what's cool is all of those things are actively on the roadmap. And if I should have actually left a link to this over here, but if you actually go in and find some of these features, you can actually, host MVP features document. So all of these things, so right now where WebAssembly is the MVP has just now shipped and been declared like done. We're done with the MVP. And the MVP is just like, can we execute WASM code in the browser? And we saw that happen, and we can do that. The next things are like, how do I build out this platform so that I can support higher level languages? As we can see there, the key bits that we're gonna need, garbage collection and threads, are underway right now. And if you want to, if you track through these issues, you can actually go find that there are Git repositories with code in them for a lot of them, and people actually working on that stuff. So that's pretty cool. It's low level now, probably not practical for widespread use, but I'm optimistic that it's going to get there. I already did that. Oh, I didn't mean to say that. Yeah, so that's kind of the future. These things are coming along. They're being supported cross-browser. I think the future for WebAssembly is really, really bright. There are some, if you go to the WebAssembly page, like the demo is actually pretty cool. It's actually like a full Unity game that they've ported to output WASM code. So like this is like not, this is just a little bit better than my demo, just like that much. But this is running a full 3D game using WASM. I haven't actually tried it yet. Hopefully it works. I didn't verify that. Seems like it's starting. Okay, yeah, it's doing something. Oh, you can't hear the little silly sounds that it's playing. Oh, look, I've got a little tank. I bet you I can shoot stuff. Oh, which one is mine? I'm moving the red tank, but when I press the space bar, the blue tank shoots. So yeah, maybe they got some issues to work out there, I guess. But it's still like using Unity, which is what real game developers use, and it actually works. So yeah, that's kind of my spiel. Any questions on WebAssembly? I'm most excited about language independence. So I see languages, maybe not Ruby, but I think it's more likely a language like Crystal, which is very closely related to Ruby and uses LLVM. I think Crystal might be one of the first ones that I'd be interested in because I think it already uses LLVM. Any languages that are based on LLVM, I bet you it will ship first. So Perl actually might be one of the first ones, believe it or not, too.
Could you give other examples of languages that use LLVM?
Perl's the one that springs to mind. I'm pretty sure Perl 6 is LLVM based. I don't know, does anybody else know of any? I mean, obviously Rust, Crystal. I could look it up, but there's probably quite a few. Anything else? Or any other questions, I mean? All right, well, that's kind of all I got. Next month, hopefully we'll be hearing about Vue.js. And if you want to talk about WebAssembly or anything, I'll hang out here for a few minutes. Thanks, everybody.